Hi, and welcome back. We're going to talk today about assignment number 1 for our celestial navigation class. So let's dive right into it. The first page is defining the following terms. So I am going to draw a little bit and define a little bit of each of our terms. So for number 1, we have the celestial horizon. So if we are on a boat, our celestial horizon is everything around us. So it's our horizon from where we are. So it's that plane perpendicular from where we are. Yes, it doesn't really go like that, but it's just the horizon from where we are. And then our zenith is the point that is directly above us. So from us, directly above is going to be our zenith. Directly below us is going to be the nadir. So our horizon is directly out from where we are. Our zenith line is directly above our head, and then nadir goes directly below. So we're making that line through us and through the celestial horizon, or the celestial sphere. So that is our zenith and our nadir and our horizon. The next one is a point of Aries. So the point of Aries is not a star. You're not going to see Aries as a constellation. It is just a reference point or a datum, or it's a point in space where many other things are referenced from. And it is technically where, if we have the equator and then we have the path of the sun. So the sun travels along this path every day, and along this path, along this path, and along this path, and then it goes for summer and winter. So where it meets the horizon, or where it meets the equator, is where the point of Aries is. But again, we are just using it as the reference point. We're not actually finding it or measuring it specifically. It's just a reference point for our calculations. The LHA is, okay, so here's our globe. Here's me. Here's Greenwich, so 0 degrees. Here's me, and here's a star. So if I have the hour angle that passes through me, and the hour angle that passes through the star, so these are meridians. This is a poor drawing of what a meridian is. So this is Greenwich. This is where my longitude is. So this one here is longitude, and this is going to be our GHA. So from Greenwich to me is my longitude, and from Greenwich to the star is GHA. LHA is your local hour angle, and that's measured from you to the star. And all of these are measured west, except for longitude. You can do east or west. But our LHA and our GHA are all measured in the westerly direction. Okay, so that's the celestial equator system. For the celestial horizon system, let's go back to our drawing of where we are. So this is our horizon, right? And directly above us is zenith, directly below us is nadir. They ask us what is the altitude. So if I had a star right here, I would be measuring the distance from my horizon to the star, and that's going to be our altitude, or our H, the height of the star, or the altitude. So we're measuring this in degrees. What is the angular distance from the altitude, from the horizon to the star? Now, zenith distance is our co-altitude, and that's from zenith to the star, measured in degrees. That is going to be our zenith distance. So it's just the complementary of our altitude. And then azimuth is the bearing of that star. So, let's see. If I have us right here, and this is north, and I'm looking down on the equator, if this is the star, I want the bearing of the star, just like LOP, or a bearing that we see. It's an angular distance from north to the star. So it's that that bearing of the star, and that's what an azimuth is. All right, and those are our vocab terms. Again, there are a lot prettier pictures than my little drawing here in the slides. So please go over the PowerPoint, or let me know if you have any questions, or I can get a better drawing, because I'm not an artist. All right, let's move on to the next page. All right, so our next section is the time diagram practice, and that is where we get our position and the GHA of an object, and then we can figure out what our LHA is and more of what's going on. So we're just practicing the time diagram. And I want you to remember the little key up here when you're drawing your time diagram. So so I'm going to write that down and we'll get started. Okay, so I wrote down our rules, and we're going to start with number 1. Number 1 told us, let's put our Greenwich, so this way is west and this way is east, and number 10. Number 10 says that our latitude is 21 degrees 18 minutes north, which we don't really care about, and our longitude is 154 degrees west, and the sun, GHA, is 090. Okay, so let's get an idea of what this is talking about. So our GHA is from Greenwich to the star and always measured west. So if it's 090, it's going to be 90 degrees from our Greenwich line. So we're going to have the sun is right here, and the sun is rising, and as the day progresses, the sun is going to move around the Earth. If this is the South Pole. And then it says our longitude for us is about 154. So this is where I am. Also, you could put M for your meridian, or for me, or however you want to remember it. And that was west, 154 west. So from Greenwich, 154 degrees. And this one was 90 degrees. So from looking at this picture, do we know if it's AM or PM? If the sun is directly above me, that would be noon. And the sun is moving along. The GHA gets bigger and bigger as the day progresses. So it's getting bigger and bigger. So the sun hasn't peaked yet over us. So this would be AM. We would be in the AM. Just so we're aware. And then our question asks us, what is the LHA and the little t, or the meridian angle? So LHA is from me to the star, measured west. So if I find from me to the star, the sun is a star, we are going to be measuring west. Okay, so this pink line is going to be LHA, because we are measuring all the way around. So, in order to find that out, we need to know the difference between these two. So, a lot of ways you can do it, you know, okay, so our rule in our site reduction form is going to be GHA plus east minus west longitude gives me LHA. So if the GHA of the sun was 090 and my longitude was 154 degrees west, I'm going to be subtracting west. So I'm going to be subtracting my 090 or my 154 from 090, which I can't do, right? So I need to add 360 to that. So I have 450, so that's this amount, 450 minus my 154, and that gives me 296. So from looking at it, from this point all the way over, 296 would make sense. It's a little bit more than 270, about 3/4, and not quite the whole way. So 296 would work. Now the meridian angle, little t, is going to be the smallest way to get from me to the star. So it's me to the star in the shortest possible route. So going all the way around is not going to be the shortest possible route. Going this way, measuring east, is going to give me the shortest possible route. So the quickest way to figure out what t is to minus 360 minus LHA to give you t. Gives me 64 degrees. So that little number is 64, where my LHA was 296. So my little t is 64 degrees, which is the shortest way to get from me to the star. Okay, let's do number 11. All right, number 11 tells us we're at 33 degrees, 15 north, at 117 degrees west, and the GHA of the sun is 235 degrees. So let's plot that and figure out where we are. So I'm going to start with the sun at 235. So from G, I'm going to measure, because GHA is from G to the star. So from G, 235 degrees would be approximately right about here for the sun. And I am at 117. So here's 90, here's 180. We'll say here is me at 117. So this angle is 117, and this angle is 235. And this is our GHA, and this is our longitude. Okay, so first, is it AM or PM? Now, remember the sun moves in this counterclockwise motion. So if the sun was over here, that would be midnight. If the sun is over here, that would be noon. So the sun hasn't gotten past midnight to the AM hours. It's still in the PM hours, moving along this way. So we are in the PM hours of the day, and we want to figure out what our LHA and meridian angle is. So we can write out our rule of GHA, add east minus west longitude, gives me LHA. And we can also see what it is here. LHA is measured west from me to the star. So from me to the star is our LHA. So when I write it out, I can write my GHA was 235 degrees. My longitude was 117 degrees west, meaning I'm going to subtract. So I have 235 minus 117. My GHA is 118. That's how many degrees I have left there. Now, my meridian angle is going to be the smallest way to get from me to the star. So, if I go from me to the star this way, that's going to be bigger than this from me to the star measured west. So my little t is the same as LHA at 118 degrees west for little t, or meridian angle. Alright, let's do number 12. Okay, so for number 12, we have our longitude of 30 degrees 15 north, our latitude, our longitude of 075 east, and a GHA of 350. So I'm going to start with our GHA. From G to the star, so from G to the star is 350 degrees. So I'm going to go all the way around, and our sun is right there. And that is our GHA at 350. And then it also told us our longitude was 75 east. So longitude is measured from Greenwich, and we're going east this time instead of west. So 75 degrees. So here is 90. We'll call this me. So this angle is 75 degrees from Greenwich to me. 75 degrees. So, is it AM or PM? If I draw out my midnight line, the sun rises and then it sets. The sun is still rotating in this counterclockwise direction. So if the sun was up here, it would be noon, and the sun is past that. So we are in the PM hours. If it gets past to here, that's midnight. And growing up would be AM the next day. Okay, so for GHA, we have our GHA is measured, or excuse me, LHA. LHA is measured from me to the star, measured west. So from me, right, M, from me to the star is going to be our LHA. So we can put this piece together, and we have our rule of GHA, add east minus west longitude, gives me my LHA. So our GHA was 350, and our our longitude was 75 degrees, and that was east. So we're going to be adding. We have 350 plus 75 gives me a large number. I'm going to minus 360, and I get 0.65 degrees. And that would make sense if this was kind of a negative 10, if you will, and this is 75. 65 degrees to there makes sense. So always good to do that mental check. And then for little t, meridian angle, we want the shortest possible distance from me to the star. So from me to the star, our shortest possible distance would be the same as LHA. So 65 degrees west. That's number 12. Okay, so on number 13, we have a latitude of 1448 north, a longitude of 142 east, and a GHA of the sun of 225. So I'm going to start with the sun. GHA is from G to the star, measured west. So from G, I'm going to go 225 degrees. Let's say that's about here, and that's where the sun is. And then I'm going to say the longitude is 142. So where is our longitude? About 142. (142 degrees from) oops. There we go. 142 degrees from Greenwich, measured east. And our GHA was measured west at 225 degrees. So what is our LHA? Remember, our LHA is measured from me to the star, measured west. So from me to the star, measured west, is our LHA. So it's going to be a pretty small number. We have GHA, add east minus west longitude, gives us our LHA. So we have 225 plus our 142 degrees east. $225 plus 142 gives me 367, which would equal 007 degrees, that very small number there. And our little t is going to be the same. The smallest way to get from M to the star would not be going east, it would still be going west at 7 degrees west. So that's number 13. Okay, so for the next part of the homework assignment, we're going to talk about the navigational triangle. So it's a review on our points, sides, and angles of the navigational triangle. And that's where we're combining both the celestial equator system and the celestial horizontal system. So for a triangle, we have 3 points. Right, here's our triangle. And the top is the elevated pole. So the majority of us are going to be in the North Pole, in the Northern Hemisphere. So our elevated pole is going to be the North Pole. And then your other 2 spots are wherever you are and wherever the star is. So that's you and that's the star. So this is going to be that geographic position of the star, and this is going to be your geographic position. So if we connect those 3 points, then we will get sides. So the sides of our triangle, and technically this is all celestial is spherical trig, so it's not straight lines, but I can use that pen. But you're on a sphere, so it's kind of, picture it like that. It's a sphere, it's a triangle on a sphere. So that triangle is just put on a sphere, so it's kind of rounded. Okay, so the sides. Let's start with us. If we were to say what our position was, we would give our latitude and our longitude. Now, our latitude has the reference of the equator. So from the equator, north or south would be what our position is. If we were to go from the equator all the way to the North Pole, that would be 90. So we call this from the pole to ourselves is what we call co-latitude, which would be 90 minus our latitude, if this is our latitude. 90 minus our latitude would give us our co-lat. So that's where we get this angle from. Now if we go over to the star, if we wanted to get the geographic position from the star, we use declination and GHA, which are similar to our latitude and longitude, but for the star. So from declination is measured from our celestial equator, and it's measured north or south of the celestial equator. So if this is our declination, from the pole to our star would be our co-dec, also known as the polar distance. So it's the distance from the pole to the star, which is 90 degrees minus your declination gives you your polar distance. So it's just 90 degrees minus. Our last side of our triangle is from me to the star. So from me to the star is what we call our zenith distance, or our co-altitude. So if we're looking at the celestial horizon system, we would have us in the middle, and then the horizon is directly around us. And when directly above us is the zenith, and when we measure a star, we always measure from the horizon. So from the horizon to the star would be our altitude. From zenith to that star is called zenith distance. The next part of our triangle are the angles. So let's talk about our angles. So from me, if I wanted to draw the angle here, this would be my longitude, and this would be the hour angle of where I am, the longitude, and this would be the hour angle, or the GHA, of where the star is. So from me to the star is LHA, and that's measured west. Here in the northern hemisphere, west would be this way, would be LHA. So the smallest possible distance is our meridian angle, which is little t, and in this case it's measured east. So that's where our meridian angle comes in. These are our hour angles. It's the difference from me to the star in an angular distance. So that's little t. And then from me, where my bearing is, if this is north, where my bearing is to the star is what we call our azimuth, or ZN. What is the azimuth of the star? What is the bearing of the star? From me to the star, but I use the North Pole, or elevated pole, as that reference. So just like if I was getting a bearing, this is north, wherever me to the star is that angle. And that's our zenith angle. Our last angle is called parallactic angle, but we don't have any way of measuring that because we're not at the star, and we don't use it in our calculations, so we don't really need to know that one. But this is where our azimuth lives, and this is where our meridian angle lives. Of course, if we are in the southern hemisphere, or your LHA is less than 180, then your triangle will be flopped a little bit differently, and there's a slide referencing that. So please take a look at that, but this is our navigational triangle. All right, thank you. Let's do some time. Okay, so our last part of the homework assignment is practicing time and converting zone time using zone descriptions and chronometer time, and how we can change chronometers, apply a correction, and go back to GMT. So we are going to get started on that. So let's go number 17. We have a zone time of 0630. We have a zone description of +5. We have a chronometer time of 11 32:17, and a chronometer error of 1:36 fast. Okay, so when and they are asking me what is the GMT time. So roughly, I want to know what GMT is, and then I can figure out what my chronometer says. So roughly, if I have my zone time of 06:30 and my zone description of +5, that would give me a GMT of, we are adding zone description plus zone time gives me GMT. So I have a rough GMT of 11:30. Now if I apply my chronometer, and that will give me a more precise and accurate, I know that my chronometer time has 11:32:17. So that 11 here tells me that this is 11 and not 23. And then I apply my chronometer error to get my actual GMT time. My chronometer error was 1 minute and 36 seconds fast, so that means I have to take it off. I need to slow it down, so I need to subtract it. So I have 17 Okay, so I have 17 minus 36, which I can't do, so I'm going to borrow 6, that's 77, gives me 41, and 31 minus 1 gives me 30, and 11. So my exact GMT time would be 11:30:41 seconds. So that's number 17. Okay, so for number 18, we have a zone time of 19:45 with a zone description of -3, chronometer time, and chronometer error. So I want to find roughly what my GMT time is, so I know if this chronometer is 04 or 1600. So I need to zone time plus zone description gives me my GMT. My zone time is 19:45. My zone description is -3. So 19 minus 3 gives me 16:45. So that tells me that this 4 here is PM. So my chronometer time is actually 16:45:12. I apply my chronometer error. I have 49 seconds fast. I need to, if it's fast, I need to subtract that. So I am subtracting 45:12 minus 49. So I need to borrow over here. And I am left with 23 seconds. So I have 44:16. So my actual GMT time is 16:44:23. And then that's what we can use to go into our nautical almanac. Alright, last question is number 19. Okay, so for number 18, we have a zone time of 18:20, a zone description of 8, and a chronometer time of 2, 18:55. So this could either be 0200 or 1400. I'm not sure. So we have to use this information to tell us if this is 2 or 14. So zone time 18:20. Zone description we have plus 8. So 18 plus 8 gives me 2620. 2620 doesn't exist, so this is actually 0 to 20 the following day. So it's the next day. We don't have a date on this, but I know it's the next day, is my GMT. So this is in fact a 2, not 14. So if we figure out our chronometer time as 2:18:55, my chronometer error is 1:06 slow. So if it's slow, I need to add it to correct that time. So if I have 55 and 6, that gives me 0:1, and I have 20 and 2. So 2:20:01 is my exact GMT time. And that is the end of the assignment. Please let me know if you guys have any questions, and we can go over before or during class next week, and I look forward to seeing how you guys did on this. I know there's a lot of information. All right, well, have a good weekend and stay safe out there. Bye.